In this video, I want to talk about class-based components versus functional components. And in this course, we have been writing all of our components as functional components and using hooks to do things like add state or run side effects. Functional components and hooks are the popular paradigm at the moment. They're the latest React syntax for writing your components. But it is worth knowing what a class component looks like because a lot of the resources out there, the tutorials out there, were written for React components before hooks existed. As a general rule, anything that you can do with a class component, you can pretty much do with a functional component, and folks tend to prefer functional components because they don't require you to know about classes, and they tend to be a little bit shorter and a little bit more modular than class-based components. So what I'm going to do in this video is go through building a couple of class-based components, turning a couple of class-based components into functional components. So I have a welcome message component, I have a button that tracks clicks, and then I have a timer component. And all of these are in this starter project that I'll have linked. So we have a welcome message class component, a timer component here that's a class component, and a click button component that is a class component. And I'm going to walk you through levels of complexity here, starting with the simplest class component, our welcome message, all the way up to the most complex, the timer class component. And with each one, we will work through converting it to a functional component and seeing what aspects we need to transform to take a class component and turn it into a functional component. So to start off, quick tour. This is just a Create React App project that's been set up inside of Index. We render our app component, which is in our components folder, app. It has a header. It has a welcome message component, a click button component, a timer component that are imported from each of these files. And each file exports a class component. What we are going to do is go ahead and create the functional version, export that instead, and see that we get the same features out of that functional component. And in that process, we'll get to compare the two syntaxes. So we're going to start with this welcome message. And our welcome message accepts a property of name. So inside of our app here, we can put multiple on the page. And each one has a separate property of name that gets passed in. We haven't really talked about what a class is in this course yet, but a class is essentially a blueprint. And from that blueprint, you can create instances, or you can create objects from that blueprint. So when we give React a class component, what it does is instantiate that class. So take that blueprint, turn it into a specific object, and then use that object's render method. And a method is just a function that lives inside of a class to figure out what JSX needs to go on the page. So I'm going to add a couple of notes here. A class is a blueprint for creating objects. When you put a class component in your JSX, React creates an instance and uses the render method to figure out what content should go on the page. And another thing that trips people up in class components is this new keyword this. And you can think in your head that this is equivalent to a reference to that object that is created from the blueprint. So let's put these side by side so that we can see this. So when we have welcome message here, inside of our app, what that does is React uses this blueprint to create an instance and make sure that that instance has a props name, which is equal to Mike. And when we put this one here, we're doing a similar thing. We create an instance from this class, and then inside of that specific instance, that object, we have a props.name. So this is equal to that instance, that object. It has a props field inside of it, which has a name inside of it. And the value is going to be whatever we pass in here. To convert this to a functional component, instead of creating a class, we create a function. I'm going to call this welcome message. And instead of having a render function, a render method here that's inside of this class, we have a single function that returns some JavaScript. So we would return this markup, and instead of referring to our props through this, we are going to make sure that we accept props as a parameter, and then we just say props.name here. So instead of exporting this class component, I'm just going to switch to exporting this welcome message, and we should see nothing has changed about the page. There are no errors in my console. It does the same exact thing. So I'll throw some notes in here as well. So as we've learned before, a function is just a reusable chunk of code. And when we have, I'm going to put these side by side again. When we have our app and we have a function component here, every time React sees that function component inside of a return, it just goes ahead and calls the function. Whatever gets returned here is put on the page. So there's no instance created. So our class here, we had it as a blueprint that you can create objects from. That doesn't exist. We just have a function here that returns some markup. So I can also, I'll put a note here, React calls this function and puts the returned JSX on the page. So already we can see that our function component is a little bit shorter than our class component. There's a little bit less we have to think about. Like we don't have to think about this keyword. As long as we understand functions, we have a good solid foundation there, then this should make sense. So that's our welcome message component. That's the simplest version of a React component here that has some props. What we're going to do next is look at our click button. So this is a little bit more complex of a component, but we've written things that are similar to this before. So looking at what it looks like on the page, there's a button. Every time you click it, the number of clicks goes up and it re-renders. So this one is a little bit more complicated, but we can see there's some state that's stored here. There's a function that runs when the button is clicked that goes ahead and takes the state from whatever it was before to +1. And when we render things out, we grab that state and take the clicks from it and put that on the page. So converting this, we're going to create a function called click button. And for storing state inside of a function component, we use the state hook. So here, this chunk where we initialize the state is the same thing as us saying clicks, set clicks equals use state 0. So this side of the equation here where we're putting the initial value is equivalent to what's happening in our constructor here in our class component. And to back up for a second, with classes, the constructor, this method is a special method inside of classes. It is called when you create that instance from the blueprint. So when this component is created and put on the page for the first time, all of this stuff runs before render runs. So this is often in a class component where you initialize your state, and a state is often a object with properties in it. So we're creating an object literal here. You will often have multiple you could often have multiple variables in here. So we could have clicks, we could have has clicked, time last clicked, and use multiple pieces of state inside of this object literal. In our functional component, use state, we can certainly create an object literal here for our state, but we are allowed to have multiple pieces of state. So if we wanted to store that last clicked, we would just use state multiple times here to set up two different pieces of state, whereas in a class component, you usually have them grouped together into an object. So as we're going, let me add some more notes. So our constructor is called when the class is instantiated. Initial state is defined there. And usually in a class component, a state is stored as a single object. And for our purposes with the functional component, use state is how we create state variables. We can use state multiple times to create multiple pieces of state. So use state here gives us the initial value of our state. And then if we look in our class component, the way that we were able to update the state, so to make this clicks number go up each time, was to bind a function to our onClick. And here we're referring to a function that lives inside the class. So functions that live inside of a class, we usually call them methods. And you're going to access them by saying this dot, whatever the name of the function is. So here we're saying, run this method anytime the button is clicked, and then use this dot set state to change the state. And this dot set state, you pass in the new value of the state that you want. So here we are saying, okay, the old value, whatever it was here, we are going to say it's a new object that has a clicks property, and that clicks property should be set to whatever the previous state's clicks was plus 1. So this structure that we have set up here, where we're setting state, is equivalent to this function that we're using here that we get back from use state. So we can just call set clicks to change the value of clicks. In a class component, we use this dot set state to change the value of the state. So let me add that as a note as well. In a class component, we use this dot set state, change the value of our state. And as I'm sort of typing this out, I want to highlight that set state, that is a method, and that comes from the fact that this thing is a component. So this class extends React.component, so it gets a bunch of things that are defined in the React component class, one of them being this .set state. So then the corresponding note here would be in a functional component, we use the setter returned from use state to update the state. So let me continue building this out. So I'm going to grab our JavaScript markup here and return that. Let's get rid of the onClick for a second. So instead of referring to the state by looking it up on the instance, like we're doing here, we're saying this.state, which is looking up the value from our instance created from the class. Here we just say clicks. We're just using a local variable. No need to invoke the idea of an instance here. So that's how we refer to our value. And then setting up this on button click, instead of creating a method, which is a function that lives inside of a class here, we are creating a local variable, which is on button click. It's equal to this arrow function. We can call set clicks plus 1. So this is doing the same thing as this, where we are taking the value of clicks, changing it to go up by 1. Drop that in here. And then let's go ahead and export click button instead of our class component. See, hopefully, no errors in our console. Click, that goes up each time. So we have taken our class component, which involved a piece of state that was tracked and some event handlers via a method, and turned it into a functional component that uses the state hook to store that state and uses local variables that are set equal to arrow functions instead of using methods here. And you can see, again, like one of the trends that we've got going on here is that our function component is smaller than our class component. And we could write this class component a little bit more tersely, but I think a general trend that you'll see is when you use functional components, they often become trimmer, and you can modularize them a bit more. One note that I want to put out there, which is a little bit more advanced and it is digging deeper into what this means in JavaScript, and that keyword is confusing for folks that come from other languages that may be used to classical inheritance. Inside of JavaScript, the keyword this is a little bit more fluid and can be changed on the fly. So what this line of code does is make sure that anytime on button is clicked, the keyword this refers to an instance of this class. If you don't do that when you do on click equals this.onButtonClick, then when this is invoked, this does not actually refer to an instance of this class. So part of the reason why we use functional components in this class is that they're a bit easier to get started and we don't have to really dive into classes, this keyword, and all of the complexity that comes with those. Okay, great. We have covered a basic component that has props. We have covered a component that has state. And the last one that I want to talk about is a component that has what are used to be referred to as lifecycle hooks or lifecycle methods. So here what I have is a timer component. As soon as it gets put on the page, it starts a timer. And when that component is removed from the page, it stops the timer. And the way that that works inside of a class component is that we still have our state that's set up here. It's the number of seconds. We're still rendering using this.state.seconds to print out the number of seconds, but we're using two methods that come from React component. The fact that we extend React component here means that we can define these and React will know about them. So component did mount. This runs immediately after a component is mounted. And then component will unmount is run immediately before a component is destroyed or unmounted. So in class components, you will often do some initialization, inside of component did mount and do some cleanup in component will unmount. So used for initialization. And initialization could be things like setting up a timer, or it could be things like starting a request to go off to an API, like the Pokemon API. some asynchronous action. Component will unmount. This is used for cleanup. And for notes, let's add a note here that class components use lifecycle methods like component did mount and component will unmount. And components here, so or a little bit of context before we talk about interval ID is that set interval, this is similar to set timeout in JavaScript, where we give it a function, which I'm using an arrow function here, that will run at some regularly scheduled interval. And the second parameter says how much space, how much time should there be between each invocation of this function. What's the interval? So here it's 1,000 milliseconds, which is 1 second. So every second, this function will be run, and it is changing the state. So it's setting this object literal. Instead of it being second 0, the first time this runs, it becomes seconds 0 plus 1, which would be 1. And then the next time it's going to go up by 1 more. The next time it goes up by 1 more. So that's what set interval does. And set interval returns to you a identifier, an ID, that then you can use when you want to clear that interval, when you want to stop that interval from running anymore. And this is really important to do because once this component is removed from the page, we should never really be calling the state, set state. We should never change the state because that component is gone from the page. And when you change the state, React will try to re-render that component. But if it's not on the page, why would React need to spend time re-rendering it? So this cleanup that we're doing here, we're clearing the interval and we're using the identifier that we got back from set interval. And this interval ID is a piece of data that we are storing on our instance of this class. So we're storing it on our object that is the instance of the class. And we're not storing it in state because the interval ID doesn't actually need to show up anywhere on the page. It doesn't influence the rendering. It is just a piece of data that we need to track so that we store it here and we can use it here. And the way that you can do that inside of a class component is to just create another property outside of your state. So if we need to share data across multiple methods, so share a variable in a class component to share a variable across multiple methods, we create a new property. So that's all we're doing here. We're saying there's this variable that lives inside of the instance called interval ID. We're setting it to something here, and then we are using it again here to clear our interval. Okay, so I think we got a handle on this and the pieces that are involved here. We have the state, we have an interval that updates the state, we return that state so that our component continues to render. Let's create a new functional component called timer, which is just a function, and we can start incorporating the pieces. Like seconds, we already know how to do that. That is just use state. So seconds, set seconds, use state 0, so that this initializes our seconds to 0, which is the equivalent of what we're doing here, and then we can return this. But instead of saying this.state.seconds, we don't have to refer to it by looking it up on an object. Here we just have a local variable called seconds. So we just use that. And if I were to export this instead of my class component and check it out in the browser, it'll say 0 seconds have elapsed. So now we need to incorporate this life cycle where we run something, we set up an interval when the component is mounted to the page, and we remove that interval when the component is removed from the page. So if you've been following along with the material in class, then you know that use effect is one of the ways that we can do that. So we've used the effect hook here to call off to our database or call off to an API when the component is mounted. So anything we put in this function is going to run when our timer is rendered. And if we specify an empty array of dependencies here, that means that what we put inside of this function will run when the component is mounted. So we can set up our interval. And I'm just going to grab this code. And instead of set state seconds is equal to this dot state dot seconds, we are going to call set seconds. And we are going to say seconds is turned into seconds plus 1. So we haven't done the cleanup yet, but we have done the initialization. And if we look at it, seconds is going up by 1 each time. And you may wonder why I used the functional form of updating the state. Maybe you would have thought, well, we could just do seconds plus 1 here, right? Instead of seconds, instead of using a function here. So if we do this, works fine for the first update, but then it breaks. So our interval here is referring to this local variable, and this local variable, it starts off as 0, and then when the interval runs, it gets set to 1. But this local variable is sort of captured at the time that this interval is created, and stored so that we can refer to it here. But it's not updated when the interval runs the next time. So this gets into the weeds of closures in JavaScript and how a function here can reach out and grab a variable outside of it. But for the purposes of this video, we'll just stick to you have to use this functional form when we're doing this interval to make sure that you're getting the previous state and updating based on that previous state. So here we are getting a new variable passed to us called seconds that always represents the previous state, and we can then return what we want it to change into. So with that, this should work. 1, 2, 3. Great. So we have the component did mount logic implemented. The other piece is that useEffect, if we return a function from useEffect, that is used to unsubscribe or clean up after our useEffect. So this would be clean up, unsubscribe. So all we need to do is make sure we grab that interval ID and then clear interval inside of our cleanup. So interval ID. I'm just grabbing that into a local variable here. And then inside of this cleanup function, we're going to say clear interval and pass in that interval ID. And with that, we should see no errors in our console, and our functional component does the mounting logic and unmounting logic nicely for us. One subtlety that I'll point out is that useEffect is technically a little bit different than component did mount. Component did mount will run before anything is rendered to the page. useEffect runs after things are rendered to the page. So there is a separate hook in React called useLayoutEffect. If you need something that you're doing in component did mount or component will unmount, or component did update, some of the other lifecycle methods, if you need something to run before things are rendered, you would use useLayoutEffect instead of useEffect. And here, this is not going to do anything different in terms of what we see on the page. There's not going to be anything noticeable, but you can see that it's pretty interchangeable. Use layout effect and use effect. So I'm going to switch back to use effect here. And so just to summarize some of the differences here, our lifecycle methods that we were using in a class, we are using the effect hook to run similar logic by expressing that there are no dependencies here for this side effect. That pretty much maps so that this logic is component did mount and this logic is component will unmount. And then we don't have these properties that we're storing that we stored in a class component to share things across our methods. Here, we're just using a local variable to share a piece of information from our mounting to our unmounting. And so now you should have an example of a couple of different class components converted to functional components, like one that just has props, one that just has some state, and one that has side effects. And with those, you should be in a good place to look at tutorials that you find online as you're working on your final projects. And those tutorials may be written with React components, but with the basis that you built going through this tutorial, you should be in a good place to think like, oh, I see a React component that is a class, and I can now convert it to a functional component and use hooks like we've been doing in class.